Okay, today we continue with the questions and past the question or the trial questions and the question. Okay, and the last question we did that was question number 38. Question 38. Okay, question 38. So we do question number 39. Question number 39. And diagram 39 shows the setup of apparatus to study the magnetic field due to current in solenoid. When the switch key is off, the needle compass point north. Okay. Which direction will the compass needle point when switch key is closed? Switch key is closed. Okay. Okay. Switch key is closed means switch key is on lah. Switch key is closed means switch key is on, and we must see the current direction lah. The current direction. Okay. And means why like this? So this current is like this. Okay, this is a positive, positive, negative. So current is flowing like this. Current is positive like this. So current is like this. So it's going to the coil. Going to the coil. Current is like this. Okay, current like this. Okay, and it's a bit difficult because cannot demonstrate, and okay. Okay, this one is we must use right hand grip rule. Right hand grip rule, but solenoid. Okay, but solenoid. Okay, and the right hand grip rule shows this one like this. Current like this. Current like this. So current like this. So it shows north this side. This north is the north. It is okay. Before switch K is on, switch K is off. So all the magnetic field direction shows north pole. All the magnetic field to show direction shows earth magnetic field. Earth magnetic field on north pole. Earth magnetic field. So direction shows north. So there's no current yet. Switch K is off. There's no current flow yet. So there's no electromagnetic field. Okay, there's no electromagnetic field. So when the current flows like this, like this, so the current like this, flow like this. So it shows direction. It's not here. North direction is here. It's north. This is west. So towards west. Okay, towards west. Because this is a magnetic field. The magnetic field. This is electromagnetic field north pole. Okay, as a thumb shows north pole. This shows the four fingers shows direction of current. It's unlike the straight wire. Straight wire is different. It's the right hand grip rule also, where we use current like this, current going up. So thumb shows current direction. Is magnetic field. Clockwise, anti-clockwise. Okay, clockwise, anti-clockwise. So this is current. Current for this is anti-clockwise. So this is the straight wire. Magnetic field, electromagnetic field for straight wire, where we use right hand grip rule also. But the thumb shows direction of current. The four fingers shows direction of magnetic field. But this is different. This also use right hand grip rule. But this one is what do you call it? Right hand grip rule. This also use right hand grip rule. But this is solenoid. So solenoid, this thumb shows direction of north pole. direction north pole of electromagnetic field. Electromagnetic field. This original north pole because no current yet. No current yet. Switch case off. So there's no electromagnetic field. So original north pole it shows all the magnetic field shows north pole. All the magnetic field shows earth magnetic field as north pole. But when current flows like this, when switch case on, when current flow like this, the electromagnetic field north pole. Electromagnetic north pole. So like this. So north pole. So it shows direction west. So it's a bit difficult to understand. You try to understand this one. Okay, it's not. It's electromagnetic field. Current like this. This 4 fingers shows direction of current, and this thumb shows direction north pole. Electromagnetic field north pole. So north pole this. So this current like this. So this electromagnetic field north pole. It shows west towards west. Electromagnetic field north pole is north pole. But in the direction of the what you call northwest, so it shows direction west, but it shows north pole. It shows north pole towards north pole electromagnetic field north pole. Electromagnetic field, this electromagnetic field north pole. The north pole, in the north pole, it shows north pole. Thumb shows the direction of magnetic field, electromagnetic field north pole, and the north pole in the direction, in the original direction, it shows west. So electromagnetic field north pole. Bit difficult to understand, but try to understand this one. And question number 40. Question number 40. Diagram 40 shows a wire PQ placed on the parallel metal rod at an angle with the horizontal. Okay. Which diagram shows the correct condition of the battery and the direction of magnetic field. Direction of magnetic field B to prevent PQ from sliding down. The answer is B. Answer B. Okay, answer B. Because this is very difficult to draw these, and it's a 2-dimensional drawing. Okay, but I try my best to teach you. Okay, the answer is B. But question number 39, answer is D. Okay, this one is like this, and the wire like this is sliding down. Wire PQ. Prevent the wire from sliding down. So the answer is the magnetic field. The magnetic field is like this. This is a magnetic field. Magnetic field, and the current direction is wire. Current direction is this, positive and negative. This is positive and negative. So from answer I teach you. So current direction. So current flow like this. Positive or positive negative. Current flow like this. So current flow like this. Sorry. Current flow like this. This is current direction. This current flow like this wire, and this magnetic field direction. The magnetic field direction. Answer B. From answer B, I'm teaching you magnetic field. So I will teach you what do you call it? This one use Fleming's left-hand rule. Because direction of magnetic field is known. Direction of current is known. Direction of force is unknown. Direction of force we have to find out, because the force is prevent the what you call metal from sliding down. Okay, so use the left-hand rule. This is a direction of current. This current direction. This one is a magnetic field direction. Okay, this is the thumb. The thumb shows direction of force. Current direction this way. Current direction is this. It is a current direction. Current direction like this. So current is like this. Current going like this, and current is going like this. Current towards Q, and the direction of magnetic field like this. The thumb shows upwards. The the thumb shows upwards. So thumb shows upwards means it will prevent the force, prevent something like this, something like this. Okay, that is this is current direction. This is current direction. Okay, I don't know. Maybe you can see or not. I don't know. Okay. Okay. This is a force. This is a current flowing. The wire PQ current is flowing in this. The cap shows current lah. Current shows like this. These are two wires sliding down, PQ, P and Q current. So this one, the magnetic field current is flowing like this. The magnetic field direction from top to bottom, direction magnetic field, and the thumb shows direction force. So this force prevent the wire from wire PQ from sliding down. So the force is like this, force pushing up. So the wire is sliding down, prevent the wire from sliding down. The wire PQ from sliding down. So sliding down. So the wire is PQ from sliding down. So this one is prevent. So the force is direction force. The force prevent. The force pushing up. If the force pull down, is force down, this wire is come down. But this wire is the force is pushing down, pushing upwards. The force the wire PQ is pushing upwards. Okay, pushing upwards. Okay, and this is the answer is answer B lah. Answer B. Okay, and okay, we continue with the question number 41. Question 41. 41 shows diagram. 41 shows simple transformer with the bulb lights up at normal brightness. What will happen if the alternating current AC input is replaced by 3-volt battery? 3-volt battery. Okay, this is something very interesting question. This one I taught you before. I don't know you can remember them now. Okay. Okay, transformer like this. Okay, transformer like this, and this is it's an AC current. It's an initial AC current. AC symbol, and this one is bulb. This bulb lights up. Okay, AC current replaced with AC current replaced the bulb lights up with normal brightness. Bulb lights up. Normal brightness. Bulb lights up. Okay. This one AC current replaced the 3-volt battery. This one 3-volt battery. 3-volt battery. Battery is what? DC current. Battery is DC current. So whether 3-volt battery, 30-volt battery, 300-volt battery, the bulb doesn't light up. Okay. The bulb doesn't light up. The answer is answer D. The bulb does not light up because DC current. The transformer only works with AC current, alternating current. Transformer only works with AC current, not DC current. Okay. I've seen this another question and answer is called when you fix it 3-volt battery. When you fix 3-volt battery, the bulb lights up once. Another answer, another question. I've seen another question, another type, same type question. Another answer is the bulb lights up once and off. Why is it? Okay, when the bulb 3 volt or 30 volt, 300 volt DC current connected, and there's a magnetic flux. There's a current flow here in this coil, and there's a magnetic flux lights up. Magnetic flux rises up, cuts this coil, secondary coil, then bulb lights up once. Then after the bulb off once. I'm trying to give another answer, another question. I've gone through before another question. The answer is that they put 3-volt battery lah. They replace alternating current with 3-volt DC battery. And what happened? So the answer is they gave. This one answer is no lights up lah. No lights up. Is answer correct? No lights up. It never lights up. But another question, another answer, same that question, replace battery, AC current replace battery. What happened? Answer. Answer, they gave lights up once and after the bulb is off. Once lights up and bulb is off. Because when the current, when DC current, when you connect the battery, the current flow like this, it's a magnetic field rises up. The magnetic field rises up, cut the secondary cord, bulb lights up. After that, magnetic flux remain constant, remain rising up. So there's no change of magnetic field. Change of magnetic field is one. If AC current, magnetic flux rise up, collapse, rise up, collapse, rise up according to current change direction. So rise up, collapse, rise up, collapse. So the magnetic field cuts in, cuts out, cuts in, cuts out, cuts in, cuts out. So the bulb is lights up continuing. So in battery means lights up only once only. So bulb lights up only once. After that, they remain constant. The magnetic field remain constant rising up. So because there's no change in current, so there's no change in magnetic field. So the transformer works change of magnetic field. So change of magnetic field, rise up, collapse, rise up, collapse, rise up, collapse. This is possible with AC current only. AC current only. So the answer for this question, bulb does not light up. Better answer. I've seen this another question. Bulb lights up once, then it's off. Bulb lights up once only, one time only. Lights once up, once only, then after that lights off. But this answer is accepted lah. Bulb doesn't light up lah. Bulb doesn't light up. Answer correct. Because by right suppose we light once and off lah, off. But this one they never give the answer. Lights once up, once, lights once up, once, lights off lah. Bulb is lights off. Okay, but okay, this is another question. Same kind of question. Okay. Question 42. A multi-tap transformer consists of primary coil of 1200 turns and the secondary coil of total 120 turns. Which diagram shows the correct connection of to light up 12-volt 24-watt bulb? The answer is C. Answer C. Because okay, this one is answer C. Answer C. And this one is 40 and answer C lah. From answer C I'm teaching you 40 and 60. So 40 and 60. So 40 turns and 20 turns. So all together the bulb here. So bulb is 60 turns. 40 and 20. Answer C. 40 and 60 turns. And 240 AC here. AC is 1200 turns. This one 1200 turns. So let's say the bulb lights up must be 12 volt. 12 volt bulb. The 12 volt bulb. They want the output voltage 12 volt. Output voltage 12 volt. So we may use the formula NS over NP because VS over VP. I did not teach this question because no time. At that time I was teaching some questions, but not this one. So NS or NP is equals to VS or VP. The NS means 60 plus 20. 60 plus 20. Okay, so we put NS lah, NS we put NS lah. And NP is NP. This is NS. Secondary coil. This secondary coil is a primary coil. Primary coil is 1200 turns. And the VS, the voltage here 12 volt. Voltage 12 volt. And voltage NP is 240. NP 240. So NS equals to 12 over 240 times 1200. Okay, this one is 20. 20. This one is 6101, so 60. So ms equals to 60 tons. 60 tons. 60 tons. So correct. 60 plus 20. 60 plus 20. So correct tons. Okay, 60 plus 20. Okay, 60 plus 20. Okay, and okay, we continue back, huh? Because I'll brighten up a little bit, so dark. Okay, and so 60 tons. NS equals to 12 over 240. NS equals to NP over NP, VS over VP. So we must VP, NP, and VP, NS and VS. Otherwise the formula, NP or NS equals to VP or VS. This formula also can be used, but P and P, S and S. But this one is we want to find out the NS number of turns to secondary call. So we put NS to NP equals VS VP. NS we don't know. Let's say we don't know. NP is 1200 NP. Primary call left hand side. And VS is a 12 volt bulb. They want light up 12 volt bulb. So this must be VS. The bulb must be connected as secondary call. Bulb or any electrical equipments must be connected secondary call. So NS is 12 volt battery. So 240 VP, 240 80. AC. 240 AC. That is called VP. So this one cross multiply, NS is 60 10. So 640 times 20, 60 tens. So question 42 is answer C. Question 43. Okay. Diagram 43 shows a model of transmission and distribution of electricity. Name the type of transformer X and Y. This one I thought is one national grid network. National grid network. So after the power station. This one is power station. After the power station, the transformer must be step up. Because power station, let's say they produce 10,000 volt. The step up transformer will increase the voltage to under 32 kV, under 32,000 or 33,000. They increase voltage so high. Increase step up transformer. X means step up transformer. Y might be step down transformer. Step up and step down. Step down transformer to houses. So maybe they send 33 or under 32,000 voltage and come to house. They put several step down transformer. Step up transformer after power station. After power station, the first transformer must step up, increase the voltage so high. Then they reduce the voltage, step down until come to house is about 240 volts step down. Okay, 1000 volt. Okay, so B, answer B, step up and step down. Step up and step down. So next question, diagram 44 shows that cathode ray oscilloscope CR is connected across a 9 ohm resistor. Okay, the bright spot is deflected from the center to screen O to O up. Okay. Okay. This question is okay, 9 ohm, 1 2 3, 1 2 3, okay, 9 ohm. This is O, is O dash, O prime. So 1 2 3, 3 boxes. 1 2 3, 3 boxes. 3 boxes. So 9 ohm resistor, 9 ohm resistor. Okay, so 9 ohm resistor. 9 ohm resistor, answer is, okay, answer is, okay, 9 ohm resistor. This one is 3 volt, this one 3 volt, 3 volt, 3 volt. So we put 9 ohm resistor is to be considered 9 volt. So 9 volt. So one same. So this one is a 3 volt per cm. 3 volt per cm. 9 volt. So 9 volt. Okay, 9 volts. Okay. This they put it 6, they put it 6 ohm. The question number, question 44, they put 6 ohm. They put 6 ohm. So 6 ohm must be 3 volt per cm. 9 volt, 9 ohm, 9 ohm, 9 volt. So 3 volt, 3 volt, 3 volt, 9 volt. So 9 volt per 3 volt per cm. So the 6 ohm, it must be, they put it 6 ohm. The next question, they put 6 ohm. 6 ohm is 2 box only, 2 box only. Because 6 ohm, 6 volt, 2 box only. So answer will be A. 2 box, answer A. So answer A. A. So it's 1 volt, 3 volt per cm, 3 volt per cm. So 6 volt, 6 volt, 6 volt per cm. 6 volt. So 3 volt per cm, 6 volt, or total 6 volt, because 6 ohm. 6 ohm, 2 boxes. 9 ohm, 3 boxes. So 2 boxes will be 6 volt. Okay, answer is A. Question 45. Which bulb lights up continuously when the switch is on? When the switch is on. Okay. This is another interesting question. There's another theory. This theory I'll never teach you. Maybe I would have thought lah. Maybe I would thought. Maybe I'll. This one is questions. This bulb here and bulb here. This one bulb here. And third bulb is capacitor bulb here, and the fourth bulb is this one. Fourth bulb is resistor. Okay, now, and the switch is K, switch is on, switch on. Okay, switch is on. So you take current flow, current flow with positive or negative direction. So this is positive. Remember this bulb is bulb P, bulb Q, bulb R, bulb S, and bulb T. Okay, the current flow is this. The current flow is this. So the current flow is this. So current can flow like this. Current can flow like this. So current can flow because diode is pitchang hadapan or forward bias, current can flow. So this bulb can light up. This bulb Q can light up and P can light up because P, the current is flowing negative. Positive direction start current and negative direction current can flow. So current can flow. Okay. But current cannot flow this direction, because current coming like this. So current cannot go like this, It's a pinchang songsang ataupun reverse bias. So this current cannot flow. But this current can flow like this, straight can flow. Current cannot flow like this, but current can flow like this. Okay, and current can flow or not? Capacitor current cannot flow because capacitor only works with AC current. So capacitor current cannot flow. So current cannot flow in R, but S also cannot. current and flow. That is current and flow. Direct and current and flow. Current. This is resistor. Resistor either way. Resistor either way. Either this way or this way. Resistor any way. So this one current. So this one current and flow. So current can flow at bulb P, bulb Q, and bulb T. Bulb T. The current cannot flow in bulb R because reverse bias. Current cannot flow bulb S because capacitor. Capacitor only works with AC current. This one DC current, battery current. So the answer is this one you have to learn, because I teach you only because you have to learn. Because this question I've seen several times. Several times I've seen this one because I've gone through about 30 or trial papers, 30 sets now. Maybe I've gone through this question to 10 years time. In this 10 years time, maybe 2012, okay, but 10 years lah. So 30 over papers I would have gone through. Maybe more than 30 papers, 30 set lah. 30 set. 1 year I will discuss about 13 set, 13 set, because last year, this year and last year I did not teach revision class, but the previous year until year 2018 I was teaching so much extensively the revision class, 3 revision class, 1 week 3 revision class, Tuesday, Wednesday and Saturday, Sunday. So revision class, so 3 revision class the whole year, January up to November, I think, January up to September, January up to October or November. We used about 30 sets of paper, 13, 14 set paper, 50 set paper, 1 year set paper, paper 1, paper 2. So like this, I taught this one more than 30 set paper. Okay, I don't know how many sets of paper. So I've seen these questions. We are done before the questions now. Okay, by the grace of God, I can teach you, but because this question, I've seen another paper also. Okay, so you must understand this one question. Okay, 45, 46, 46, 46. Diagram 46 shows a full wave rectifier unit. Suggest a modification as to do the circuit in diagram 46 to obtain a smooth full wave reflection. Okay, full wave reflection. So smoothen. So we must add capacitor. We must add capacitor to resist the R. Add capacitor resist the R. Okay. Yeah, I'll finish this question. Question 47 shows a voltage time graph, the input and output of the gas logic gate. Identify the logic gate. Identify the logic gate. Okay. Identify logic gate. This is difficult. This one, NAND. This question I didn't teach you this one because this is another logic gate question, type of logic gate. This logic gate question, this one we call it the graph paper, the graph question, logic 1 and 0. Okay, so this one, okay, logic 0 and this is Vx. This 1. So this one is like this. Like this. So this is logic 0. 0 means down. Logic 1 means 1. 1 means must be upscale. So this one must be 0, 0, 1, 0, 1, 1. This Vx. Okay, and Vy is V1. This one 1, 0. Okay, this one is okay, like this. Okay, this one must be 0 here, 0, 1, 1, 0 here, 1. So 1 means first story. 1 means first story, 0 means ground floor. Okay, so based on this the answer is I teach you this based on answer lah. Okay, we will try one by one. It's very difficult. The answer is D, NAND gate lah. NAND gate. Okay, it's an NAND gate. NAND gate means like this. NAND gate like this. This one is output. This is VX. This is VX. This is V1. So okay, you put it 0, 0, 1, 0, 1, 1. Put from the left hand side, 0, 1, 0, 1, 1, and this one is going to be 0, 1, 1. Sorry, 0, 1, 1. 0, 1. 0 means ground floor, 1 means first floor, first story. 0, 1, 1, 0, 1, 1, and 0, 1. So, you must take from left to right, left to right, left to right, left to right. Okay? When you do logic gate, right to left. When you do logic gate, right to left. Okay? The 1 and 1. So, AND gate. AND gate is A times B, bar, A times B. So, 1, 1. 1, 1. If you 1 times 1, 1 times 1 is 1, but this is NAND gate. NAND gate must be 0. 0. This one must be 0. This 0. And this one, the second one, first one, this one, first one. Second one. Okay? Second one, 1 and 0. 1 and 0. AND gate 1 and 1, 0, 0. But NAND gate is 1. Second gate. Okay, 0 and 1. 3. 0 and 1. 0 and 1. Okay, 0 and 1, AND gate is 0, NAND gate is 1. 3. Fourth one. The fourth one. 1 and 1. 1 times 1, AND gate is 1, but NAND gate is 0. This fourth one. And the fifth one, 0 and times 0, AND gate is 0 times 0 is 0, but NAND gate is 1. This fifth one. This one fifth one. So 0, 1, 1, 0. Okay. Next one. This output, output must be, okay. The output must be, the output is V2 lah, the V2 the output, VZ output. The VZ must be, okay, VZ, output VZ. Okay, this, okay, VZ, 1, it's 1, 1 and 0, 1 and 0, 1 and 0, 0, and 1 here, 1 and 1 here. So 1, 0, 1, 0, 1, 1, and 0 here, 0. So correct answer 1, 0, 1, 1, 0. 1, 0, 1, 1, and 0. Correct answer. So answer will be NAND gate and NAND gate. Okay. If you don't understand, I will teach you again. Okay. And question number 48. An unstable uranium-23892 nucleus decay to stable 22688 iridium nucleus. What is the number of alpha particles and beta particles emitted during this process? Okay. Okay, this one we must okay, uranium 23892. So become X lah. Let's say alpha X, 234 and 92. 92 must be 234, 92 must be 84 lah. 84. 86, 88 because 4 nuclear number reduced and 2 proton number reduced to 90. So another alpha. So Y. Let's say Y. 230 and 88. 88, 230, 88. Okay, 230, 88. So another alpha. Z lah. Z 226, 226, 86, 86. But this one radium 226, 88. So must be this one. Maybe X, Y, and Z. Maybe A lah. Let's say A. 226, 87. Beta. Beta means plus 1. Plus 1 proton number. The nuclear number remains same. Nuclear number remains same. The proton number plus 1 plus B. 226, 88. So this is 226, 88. So this B is P is equals to radium 226, 88. B must be radium 226, 88 by radium. B must be radium 226, 88. 226, 88. Okay. So the last answer is must be 226 and radium is 88. So nucleus of uranium 234, 238 minus, if alpha particles means minus 4 nuclear number, minus 2 proton number. Minus 4 nuclear number, minus 2 proton number. Minus 4 nuclear number, minus 2 proton number. Because 2 to 6, until 2 to 6, no. So 3 alpha. 1, 2, 3 alpha, 86. Then beta, 1 beta, 2 to 6, same number. Beta means nuclear number same. Proton number plus 1. Okay. Then another 2 to 6 will be 2 to 6. Same nuclear number. Same nuclear number, proton number add 1. Add 1. So 87, 88. So it's another beta. Another beta. So beta. This beta. A to B. 2 to 6, 87, A. Another beta. 2 to 6, 88. 87 plus 8, 1. So 2 beta. So 3 alpha and 2 beta. 3 alpha and 2 beta lah. So the answer is question number 48 is answer B. 49, the process of splitting of nucleus of an atom into lighter nuclei is known as nuclear fission. Heavy nucleus split into 2. Heavy nucleus split into 2 become 2 lighter nuclei. So that is called barium krypton lah. So uranium bombard uranium with a neutron, and the uranium split into barium and krypton and plus 3 neutron plus energy. So split into 2. So this nuclear fission process. And the half-life of vanadium 48 is 16 days. A sample contains certain amount of vanadium 40. After 64 days, only 16.25 gram of sample still remain. What is the initial mass of the vanadium 48? After 64 days, then 16, 32, okay, 4 half-life lah. Okay, 4 half-life. Okay, 4 half-life. Okay, 16.25 gram. This one going backward, going forward divide by 2, going backward, that is this one 32.5, 16 days. 16 days. Okay. 16.25. So this one 16 days. So 32.5. Another 16 days. 64.65. 64 times 2 times 2 times one is times 2, so times 2 because going backward. So 32.5, so 32, 64, 65 gram. 65 gram. And this one 60 days more. Another 16 days more. So another 16 days more is 65, maybe 100, under 30, under 30 gram. Okay, another 16 days more. So another 16 days is under 30, 260 gram. 260 grams. So 16 for half-life. 16, 16, 16, 16, 64 days. 64 days before. 60 days before. They're not asking after. After means going forward. Divide by divide by 2. Half-life divide by 2. But this is before. We done some question like this before. Okay, before. Before means times 2. Times 2. So times 2. Going forward is divided by 2. So the answer will be 260 gram. 260 gram. Okay. We finish the question paper 1. Okay, paper 1. We finish paper 1. And paper 2, I will discuss one question to you. Okay, because the time is not paper 2. Paper 2 question number 1. Question number 1. Paper 2 question number 1. Okay, this will take some time. Huh? Okay, this one paper 2. Okay, paper 2 I posted to you last week. Huh? I asked you to do the questions. Okay, paper 2. Paper 2. Paper 2, huh? Okay, question number 1. Diagram 1 point shows a mercury thermometer. Paper 2, section A. Section A, first question 1. And what is the accuracy of thermometer? Okay, accuracy of thermometer. From because thermometer, you must see the thermometer. You must see the thermometer 0 to 10 or 10 to 20 or 20, 30, anything. So maybe 0 to 10. 0 to 10. Okay, okay, it's not very clear, but it's on 10, it's on 0. So 0, before that is negative 10, negative 10, negative 0, okay. So 0 to 10 or 10 to 20 also. So you must have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 divisions. You must see 10 division because there's a one division, something like that. So, long and short one. So it's a 10 division. So 10 division equals to 10 degrees Celsius. 10 degrees Celsius. So 1 division equals to 10 degrees Celsius divided by 10 equals to what? 1 degree Celsius. So the accuracy of this thermometer is 1 degree Celsius. Accuracy of this thermometer is 1 degree Celsius. And question number B. What is the function of X? Okay, now what do you call it? This is thermometer. Okay. Okay. This one thermometer. Okay. Okay. This one is this. Something like that. Like this. Okay, this one they asking this. Okay, what is the meaning of it? What is the word? What is the meaning? What is the label? What X means? X means it's called constriction. X means constriction. Constriction. They never asked this one, but I give this one. They never asked the meaning of this one. What is the word? Constriction. What is a constriction is to function. Question B. What is the function X? X means constriction. To slow down mercury flow back to the bulb. To slow down mercury flow back to the bulb. So you slow down. curve down, and so it slow down. So it never drop directly, drop immediately. Okay, the temperature drop, so the mercury doesn't flow immediately flow down. So it flows down slowly, slowly, and go back. So if temperature drop or temperature decrease, the mercury also flow down, and constriction slow down and go to the bottom. So it doesn't drop drastically, Okay. What is the temperature? Why is the temperature of the hot water taken when the mercury stops expanding? Because when the thermal equilibrium is reached. Okay, you stop expanding. So the temperature of the hot water and the temperature thermometer must be same. So then call it thermal equilibrium. Give one suggestion how to increase the sensitivity of the thermometer. Reduce the diameter of capillary tube. Okay, diameter. It's not diameter. It's not capillary tube. Reduce the diameter of capillary tube. You reduce some more, so its sensitivity of the thermometer can be increased. Reduce the thermometer. This is diameter of the capillary tube. Capillary tube is where the mercury goes up and come down. Capillary tube is the mercury goes up, come down. So it's reduce the diameter of the capillary tube. It's capillary tube. Or another word, reduce the bulb. Use a smaller bulb. Another answer for this: use a smaller bulb. Okay, I'll finish this question with this question. End up this one. Next class, maybe I see you question 2 onwards. So meanwhile you can do question 2, question 3, question 4, and question 5, and you can do this essay question also. Okay, I finished on this. Okay, thank you very much.